All right, Math 15, it's Mr. Paul sending you a quick video here. I wanted to shoot a video on a couple of different strategies for doing word problems, especially with ratios, because many people have different strategies. If it works for you and you get the right answer, go for it. I have a system that I spent a couple years researching that means that if you get good at it, you always get the small points that many teachers deduct for not doing certain work. Okay, so I'm going to show you a system called the 4 quadrants. Now I'm going to be using a highlighter for some of this stuff. If you don't have a highlighter, come up with your own system. You can underline things like this. Instead of underlining, you can also square, something like that. You have to come up with a way that's going to work for you. I recommend students carry one different color pen or pencil with them, even into exams. So what we're going to do is we're going to look at these 4 things. 3, 4. And the first thing is we got to look at numbers. Ultimately, when we're doing math, it doesn't matter what the problem is about. It's going to come down to an equation of some kind. What is the question? A lot of students will solve one part of a question and miss the second. A good hint is that if it's 2 points, there's probably 2 steps to the question. So we're going to find a way to quickly identify that. Then you're going to look at it like science. What do you know and what is unknown? And the very last thing is this. What can you fill in? What gaps can you fill in? You have to think through the problem even before you start to solve it. All right? So very initial step is to quickly read the question. You're not looking for information, you're just getting an idea. So number 1 here. Number 1. John is an avid hiker who has gone 11K in 3 hours on his way to a backcountry campground. He is 65% of the way to his destination. How much further does he have to travel to arrive at the campground? Great, now we go back. So the first thing we're going to do is we're going to look at numbers. So he has gone 11 kilometers. That's important. 3 hours. Might be important. He is 65% of the way to his destination. Now, here is where I would change. If you're underlining the numbers and the key things, circle the question. The big question is how much further does he have to travel? Now, in the 4 quadrants, I want you to imagine we split this up. You don't actually have to put the lines in, but start separating your answer box into a couple of different sections. The first thing that I would actually do is a little contrary to what a lot of people teach, is I would actually write your sentence. How much further does he have to travel? So I know John has blank kilometers left to travel. Now I know what I'm searching for. Okay, it makes it really clear if you already write the sentence. Now the next thing I do, I teach my students, use it or not, is to actually cross out everything that's not important. So what do I know? First box, I'm going to deal with my knowns and unknowns. So the first thing I know is he's gone 11 kilometers. This is in 3 hours. We know that. Okay, 11 kilometers equals 65% of distance. Now, what do I not know? First thing I don't know is how much farther he has to travel. So I would give that a variable. So x equals distance left. And we also don't know y is the total distance. So there's two things I don't know. You could choose one of those or you could use both. The other thing I would do in here is I know 11K is 65 kilometers, right? So how much does he have left? Well, this also means that he has 35% of the way to go. How did I get that? Well, 100% would be 100. So 100 minus 65 gives me 35%. Next thing, over here, I always encourage students to do a little diagram. And these don't have to be fancy diagrams. But what it does, it makes sure that your brain starts to see the whole concept. So this is the start of the trail. This is where John is. So John's about 65% of the way. Now here, this is 11 kilometers or 65%. Does this question ask anything about time? It doesn't, does it? So for this question, I actually don't need that. Okay, so I don't even have to put that in because it's not really that relevant. He has this left to go. So this is 35% of the way, and we called that x. So this distance here is x. I also have this. The whole distance is y. We may or may not need that. So I have my diagram. Now I can start to set up my ratios. This area down here. So first one, this is your info. Second one is your diagram. Last one is your sentence. This is where our big math is going to happen. So I'm going to use this with ratios. So I'm going to use part over the whole. Really consistent way to set things up. So I know that he has gone 65% of the way. So let's put that in. 65% is over 100. That's going to be equivalent to, well, we know that 11 kilometers is the same as the 65. 11 kilometers over x. Now, many of you solve this in different ways. I am an avid fan of cross multiply and divide. Right, that's just how I teach and how I solve. So I'm going to cross multiply and then divide. So I'm going to take 11, multiply that by 100, then I divide that by 65. X is going to be 16.92. 16, we'll just call it 16.9. Am I done? No, because what did I just solve? I just solved actually for the total. So I should have put y in there because I just solved for this total distance. So now I need to find how much he has left, which is going to be the total minus 11 kilometers. I now know the total, so I can put that in. 16.9 minus 11 kilometers. See how I'm always working in formulas? This is going to be a huge asset as you move forward. So that's going to be 5.9 kilometers. I can take that, 0.9 kilometers. There we go. Now, could I have done this a different way? Absolutely. If I want to take a look at solving just for x, well, I can have another ratio here. So this is another way you could set this up. The reason I ask students to do this part here, where we're finding out how, because you can get to this 5.9 in one step. Remember, ratios, we can decide what they are. So this ratio I'm going to set up over the percent over the distance, over kilometers. My percent on the known was 65% over 11 kilometers is going to equal 35% over x. So you see what I've done there? I've just set up a different ratio. So let's try this one. How do I solve it? I cross multiply and then divide. So I'm going to get 35 times 11 equals divided by 65. Lo and behold, x equals 5.9. So from a teacher's standpoint, what this does, even if you don't use these little lines, I can see you've identified what you know and what you don't know. I've seen your math. I see the visualization, and now I also get your sentence. This is worth at least 1 mark as you move through. Okay, so that's one question. Now this B, I'm not going to go over this. That deals with a lot of extra work that we don't need to look at. Let's take a look at one more. Okay, I know this is going to be a longer video, but I think it's important. So in this one, I'm going to set up my quadrants. And sometimes I like to set my quadrants up a little bit different so I have more room to do my calculating. So Winifred invested $7,800 and earned 70% interest over the course of a year. What is the total amount of money in her account after a year? Now we go in. What are the numbers? Okay, numbers. $7,800. Earned 17% interest. Okay, over the course of a year. What's the question? What is the total amount of money after a year? So those are my questions. Now let's go into my knowns and unknowns. So we're starting. So the initial is 7,800. Okay, so I've got that. Now I can take all this out. I don't need that anymore. Okay, 17%. So earned 17%. Is there a point in me saying, well, then there's no point in finding out the opposite of 17 because that's not part of this question. So what am I looking for? X is going to be the initial plus the earned interest. There's my formula. I've already got my formula ready to go when I'm done. So before I do the diagram, Winifred will have, and you can put this down lower, right? You can move that down. Blank amount of money after a year. Great. Do I need a picture? Well, I could. I've got this. It's going to end up being bigger because we are adding interest. So the number has to be bigger than 7,800. Sometimes your diagram can be really small or you don't need to use it. Now let's jump into it. Let's do our whole part over whole. So what is the part? Well, the part is our 17%. So I get 17 over 100 is going to equal. Now, what do we put here? Should we put the X on the top or X on the bottom? See, this is where it gets a little challenging. We can find out what 17% of 7,800 is. Okay, that's generally how most people do it. But that's not going to be my final answer. 17 times 78000 divided by 100. So 17%, X is going to equal 13,260. Am I done? No, I need to do my little equation there. So I'm going to take 78,000 plus 13,260 to get the answer 78,000, 91,260. Okay, that's pretty good. That's a pretty good increment. Now, how could we do this in one step? This is when it pays to start thinking through things. So the way we can do this is that we're not just earning 17%. If we want to find out the total, we could also calculate 117%. So this time, let's do it again. We're going to go part over whole. It's going to give me 117% because we're adding this 17% to what we already have, equals X over 7,800. So what is this telling us? This is telling us what 117% of my total would be. And this is going to end up with, I'll just do it to prove it, 17 times 780000 equals, divided by 100, I get 91260. So with this, I end up solving the entire 91260 after a year. I can solve it in one step or two. Doesn't really matter. Last one. Okay. This is one that's very similar to one of the ones in one of your what is it called? Assignments. So I'm going to split this up, give ourselves a little bit more room, and let's go. So, since the pandemic, Mountain Equipment Co-op, we'll put that up there, can put 17 people through their store in 25 minutes. How many people can they put through their stores in 3 hours? What is the hourly rate of people through the store? So let's go through it. Red numbers. 17 people through their stores, 25 minutes. That's pretty much all there is. Next one. How many people in 3 hours, and what is the hourly rate of people? So we have two questions here. So I have one question and two questions. So first one is number of, MEC can put blank number of people through in 3 hours at a rate of blank people per hour. All right, now get rid of all this. None of this matters anymore. What do I know? I know 17 people per 25 minutes. The minutes is key here. What I'm looking for is a number of people in 3 hours and the hourly rate. Let's call this one X. Okay, so here again we could do a little picture here. We have 25, 17 and 25 minutes, and we're trying to go number of people X out of 3 hours. Okay, and again, sometimes the diagrams don't make sense. I usually do it just so I know. All right, let's set up our rate. So we're going to go part over whole. Label what your ratios are. It makes it much clearer for the person marking and for yourself. So my part, I'm going to have 17 people in 25 minutes. It's going to be equal to, now I need this in hourly rate. Let's do the hourly rate first. This is going to be y over 60 minutes. Right, so I don't know how many I can do in an hour. So we go 60 times 17 equals divided by 25. It's going to give me 40.8. Now that's a raw number. Really that's 41. Okay, so this is 41 people per hour. You can't put 0.8 of a person through. Now so we could do this, and now we can multiply this by 3. 40.8 times 3 people, or 41 times 3, is going to give me roughly 123 people. 2 steps. Step 1, step 2. Or we could also take this here, instead of 60 minutes, we could turn this into 160, 120, 180 minutes. And this will take us right to that point. Let's just try that. 17 times 180 equals divided by 25 gives me 122.4. So that gives me 122. Right. So remember, because we have to round into that, we're going to have a slight variation. All right, so that's the 4-quadrant method. And again, you don't actually have to write in these lines, but put in what you know and don't know. Can you do anything? 3 hours. You could also put this as 180 minutes. It's your notes. This is going to be your equations. Up here, your diagram, and then always a sentence. All right. I hope that helps. I know a lot of you have been struggling with that. It can be applied in so many different ways. If you have a system that you prefer, then go for that. Okay. It's just an idea. Thanks so much. Have a great day.